Welcome National 5 to lesson 11 of Homologous Series. So as usual, there's a wee starter. So question 1, I want you to draw and name the functional group found in carboxylic acids. I want you to name this molecule and that molecule. I want you to draw butanoic acid, and I want you to draw 2-methyl pentanoic acid. And question 4, give me 2 uses for alcohols, okay, not carboxylic acids, alcohols other than drink. Okay, so pause the video, do the questions. I'm going to go over the answers just now. So question 1, draw and name the functional group found in carboxylic acids. Of course, that is the carboxyl group. You can draw it like that, the full structural formula, or the shortened structural formula. Okay, so hopefully you both got that. Question 2, so this molecule here is ethanoic acid, and it's ethanoic acid because you've got 2 carbons and it's got the carboxyl functional group, so ethanoic acid. The next one, 3-methyl butanoic acid. Why is it that? Well, you always start on the carbon that's attached to the carboxyl group, so 1, 2, 3, 4. We've got a branch with 1 carbon, so that's a methyl group. 4 carbons in a chain, so 3-methyl butanoic acid. Okay. Question 3a, draw butanoic acid. Very simple. It is 4 carbons in a row with a carboxyl group and 2-methyl pentanoic acid. Pent means 5, so you've got 5 carbons in a row. 1, 2, 3, 4, 5. Oh, I've made a wee mistake, so it's 2-methyl, so you should have also a branch on the second carbon as well. Okay, so well done if you got that. And question 4, give 2 uses for alcohols. Now remember, if it was carboxylic acid, that would be, you could use it in foods or cleaning supplies. If it was food, it would be vinegar, which is ethanoic acid. Yeah, just remember that. Ethanoic acid is vinegar, but it's asking for alcohols, okay? And the 2 uses for that are fuels and solvents, okay? Right, so what we're going to do, our heading today is properties of carboxylic acids. This should be a relatively straightforward lesson, shouldn't take us too long at all. We do need to go over the general formula. I forgot to do that last lesson. So the general formula for carboxylic acids is CnH2n plus 1, and then you've got the COOH. So every single carboxylic acid follows that same general formula. Okay, so that is for carboxylic acids. Now remember, alcohols, very similar, CnH2n plus 1, but instead of the COOH, you've just got an OH. So make sure you can tell the difference between the two. Yeah? Right. Again, just before we get right into the properties, I want us to do the shortened structure. Okay, I'm only going to do 2 of them. It's very straightforward. So we've got methanoic acid, because we've got 1 carbon, and let's go for propanoic acid. So 3 carbons, and just notice, you might have noticed in the starter, usually you would draw it at an angle, but sometimes you can just keep it like that. Okay, doesn't really matter what one you draw. Usually though, you would draw it at an angle, but it's not the end of the world. So if we wanted to draw the shortened structural formula for methanoic acid, you write what you see. So we see a H, we see a COOH. Yeah, that's it, very straightforward. And for propanoic acid, we split it up between the carbons. We see CH3, CH2, and COOH. Okay, we did talk about the shortened structural formula briefly. Just wanted to go over it again. Okay. Right. Next thing we're going to look at melting and boiling points. Okay, and the good thing about this is you guys have already done it. Okay, because we did it with alcohols and it's the exact same idea. So let's just say we'll write ethanoic acid has a higher melting and boiling point. I'm just shorthand that, MPBP. So ethanoic acid has a higher melting boiling point than methanoic acid. And the question, quite simply, why? Okay, now I put this as an extension, one of the extension questions was this, and the people that handed it in, perfect, okay? So, why has ethanoic got a higher boiling point than methanoic acid? It's the exact same idea as what we spoke about with the alcohols, okay? So, ethanoic acid has, what does it have? It has more carbon atoms, okay? If it's got more carbon atoms, what does that mean? Therefore, it has stronger, okay, in brackets we can put more, okay, if we've got more carbon atoms, we've got stronger or more van der Waals, okay, and if we've got more van der Waals, more energy is required to break them. Okay, so exactly just what we would write for the alcohols, more carbon atoms, stronger van der Waals, therefore more energy is required to break them. And what does that mean? It means it's got a higher melting and boiling point. And that is it. Yeah, that works for any carboxylic acid. So it could be the question could be, why does pentanoic acid have a higher boiling point than butanoic acid? But it's the same idea. Pentanoic acid has more carbons, got stronger van der Waals, more energy is required to break them. It's the same thing you're writing over and over again. Okay, so when I ask you about melting and boiling point, think about carbons, think about van der Waals. Okay? Right. I'm just going to, in fact, I'll do a wee, suppose I'll do a wee diagram. So that's our methanoic acid, and you can see we've got one wee van der Waals there. However, if we draw ethanoic acid, what you'll notice is that we actually have more van der Waals. They're stronger. Okay, so they're stronger, and that's why, it's because we've got more carbons, and that makes sense, yeah? Right. Next thing we need to talk about is solubility. Okay, and we've briefly spoke about that when we did alcohols. Yeah, I told you, for the most part, alcohols are soluble in water. I'm going to expand that a wee bit when we talk about carboxylic acid. So, So make a wee note. So carboxylic acids tend to be soluble in water. Okay, and what that means, it's able to dissolve. Okay, so this is the case for methanoic acid through to butanoic acid. Okay, so usually you find that methanoic, ethanoic, propanoic and butanoic, they tend to be soluble in water. However, when you start going into like pentanoic, hexanoic, heptanoic, octanoic, etc., that's not really the case. Okay, so why is that? Yeah, I'm going to make a wee note there. Okay, so the more, and this is the important part, the more carbons in the molecule, the less soluble it is. Okay, and that works for alcohols as well. Okay, so why is ethanol less soluble than methanol? Because it's got more carbons. Okay, and you need to know that trend. Yeah, so I'll try and summarise that. So increasing carbons okay, so as we increase the number of carbons, there's a decrease in solubility. Okay, so propanoic acid is less soluble than ethanoic acid. And again, if we link in the alcohols, pentan 1-ol is less soluble than, let's go for butan 1-ol. And why? Due to having more carbons. Okay, and you need to know that, that's so important. Yeah, the more carbons we have in a molecule, the less soluble it becomes. Yeah, right. And the last wee bit, okay, I did say this was going to be a relatively short lesson, is the pH. Okay, now you guys haven't done pH since second year, I believe, but it's an acid. Okay, I'm just going to give you a wee sort of remember, a wee note on it. Okay, so if you can remember from second year, the pH scale ranges from 1 to 14. Yeah, acids have pH of less than 7. Yeah, can you remember what has a pH greater than 7? Hopefully. Alkalis have pH of more than 7. And I'm just going to fill this up a wee bit. And neutral solutions, that's like water, salt. Neutral solutions, if you dissolve the salt, neutral solutions have pH of 7. Yeah, bang on 7. Now, we're dealing with carboxylic acids. Yeah, so that should hopefully give you a wee clue. So carboxylic acids have pH of less than 7. Yeah, and I know this sounds so silly, but a lot of people don't realise that carboxylic acids are acids. And I know that sounds crazy, but people don't make that connection. So just remember, carboxylic acids are acids. The pH is less than 7. Okay? And that's it. That's us done alcohols. That's us done carboxylic acids. We've done alkanes, cycloalkanes. I'm going to put up some work on teams now. Okay, so make sure you get all these notes, and yeah, I'll see you on teams. Right, see you.